Let's see another query. And this particular query, so the query we have here using two tables to join, right? So we also know for any condition like the select condition, and also the condition under the join symbol here, they all show up in the where part. Okay, and this one actually related to the projection of what the attributes do we need. So this table, this query eventually give you four columns, right? So the query result itself is a table format, and we have first name, middle, initial, last name, and address here. Okay, we have that, and also how many records eventually show up here depends on what is the filter here. And we can have a duplicate, right? This is another one I mentioned. So we can have two exactly the same, and they will both stay in the table in SQL query. So let's move on to the next query. So this query, also we did this in relation algebra, right? And if you think of what we did, how we actually connect both approach together, you should be able to handle this. I remember that the front part, we can have like this one has two tables, but we can have many tables and just using comma to separate that. So I want to make this into an in-class exercise to give you a chance to try to see this query if you can do it or not, or which part you know how to do, which part you don't know how to do. I give you, let's see, 4 minutes on this. How about that? Okay, so let's see how to handle this. First of all, let's go back to the schema. So we want to project located in here, and we want the controlling department and the manager's information. So from here, we can see for project, we have a location. So using that location, we can do a filter on the existing project. And we're using this one, point to here to indicate which department control this project, right? So remember this foreign key, primary key, always useful. And we found out, oh, that's the controlling department. Once we know the controlling department, we know the manager SSN. And once we know the manager SSN, we can use this as social security number as the one to identify the name of the employee here. So that's the way to do this. So we did a relation algebra one, right? So remember we did a selection on the project, right? So if we do select from where, and the front part, we need the project table, right? So the selection, we want to get Stafford. And also selection has a condition. So before I forgot about this, let me write down directly here. That is okay, so that's what we have here so far. I want to know project number, controlling department. We need the controlling department, right? So how can we get to the controlling department? We actually utilize the department table. And so we know we use project table. And we need the department table. When we have two tables, remember we need to know whether they are Cartesian product or not, right? And actually not, we are doing join, right? And in the relation algebra, we know, so this is the controlling department. We know we have a condition here. So what is the condition? we specify project and the department. Let's go back one more time. Project and department. So how do we say a department control project? That's this one, right? So DNO, D number, okay, that's the condition. So as a result, I'm going to put that condition into this. Put N here, and that's D number. DNUM equal to D number. All right. Okay, and then I get to the controlling department. Once I get a department, controlling department, I have the manager assistant, right? I have the manager assistant, but this one asks manager's name and birthday. So we also know, oh, go too far. We also know that once we get rid of this, once we know the social security number, we can join with the employee table on this to get everything like name, address, salary, everything, right? So that's why when we move on to here, we can join this result with another table. That's the employee table. And we have condition here. So we can go ahead and put a condition here. That is okay. So I have all the condition done. This is joint condition. This is so this whole thing is joint condition, and this is a joint condition, and I'm done with the query. So the last thing I want to figure out is the select. When we see select, I want to see project number. So put P number here. Okay, and I need a controlling department number. So this can be DNUM, also can be D number. They have exactly same value. So either way, I have last name. Right. Okay. One more thing we need to see is any attributes showing here. Okay, so this part you don't need this anymore. This is not a notation or anything, just scratch paper, okay? Just show you how you lead the relation algebra run to SQL, that's all. Okay, so once you have this done, before you say I'm done with query, you need to check the attributes. So you need to first of all, you need to know, are they coming from my database? And yes, we do have two tables, right? So very basic one. And the second one, you want to see the attributes in select and in where. Are the attributes coming from the two tables or not? So for example, P number is coming from project, so that's good. And DNUM coming from project, that's good. So every single one need to coming from one and only one table. So if you have ambiguity, say if you have something you don't know which table belong to, can belong to both table, then we have issue. Okay. In this case, every single one is coming from the table, right? So we are good here. All right, I forgot the employee table. I put a condition, forgot to put on that. Yeah, sorry. Okay, so you definitely need the employee table because I need to join 3 tables. All right. Okay, any other mistake? No, okay, that's all. Okay, so now everything's coming from only one table, no ambiguity. So in case there's ambiguity, one way we can solve the problem is we can use table name dot attribute name to restrict the attributes coming from where. So this prefix with table name, say we say employee dot last name, department dot D name. This is sufficient to say the name, D name is coming from department, last name coming from employee. This example, using the existing schema, we don't need the employee department the table name because there's only one L name in the whole schema. There's only one D name in the whole schema. So this is not required. So even in the case you don't require table name, you always can write down like this. So this is always okay, although this part is optional in this case. But just people usually don't do because they take a longer time to type the table name. But it's okay, always okay to put that in. So which one actually make difference is this one. So this is the one, if we take a look about, if we take a look at employee table and department, department table and the department location table, we have a D number here and D number here. So if in a query, you just put the D number, and this query can cover both department and the location, then this D number has ambiguity, right? So remember relation algebra, we use this, right? And in SQL, we have more than one way to handle this. One way to do this is restrict. So we can say department dot D number. Once we do this, we restrict the number is coming from department. In this way, this particular variable has no ambiguity just because of the restriction we put the table name here. Okay. Okay, and so let's see this example using this. Okay, so say I have a query that ask to get a department name and the location of each department. So this is a query you know how to do in relation algebra. So if we do this in SQL, how can we do that? Let me show you how to using this to solve the problem. Okay, so I want to see department name and the department location of the department. So what I need to do is, so let me just write down here since I have the schema with me, and I can always remove that after we finish. Okay, so let's see how to do this query. We have more than one way to do this. And keep this query, I'm going to do this in the next approach using the same query, right? So we do select and from and where here. So the from part, I know I need to join department table with department locations because I need to know department name with each of the locations here. So what I need to do is I take the department table. Okay, and the next table is this location. Okay, so I have that. Okay, and so for the where, I know I need to join this one with this one as a condition, right? So here, I need to restrict. So when I say the number here, I need to restrict where this D number coming from. So what I can do is, so if you just put the D number here, that's wrong. So for example, if you try to put the D number equal to D number, if this is what you try to say, because I have two D number, this is wrong. We have to do something. So I'm showing you one approach to do this is using the table name. So I can say department, okay, dot D number. And then the other one, I restrict this one to be like that. So this way, you see, I restrict this. Now, no ambiguity here. And I need to do the select statement. Then so in the select statement, I need to get the D name. And since the D name has no ambiguity, then put D name is good enough. But if you want to put department.d name, that is also correct. Okay. And I also need a delocation. So same thing for delocation, right? And this one has no ambiguity. So that's why I can put delocation without put the table name before that. So that's for using this table name here. So the next thing I want to introduce is called it's called alias. Okay, and instead of using this example, I'm going to give you the same example I just showed you. This one. Okay, so what is alias? Basically, that means alternate name for the table. So you give another name to the table. That's all. So like this one, right? So let me get rid of this so I have a little bit more space. So for example, from department, I can give a department another name. So I can say as, okay? So remember any keyword, doesn't matter, uppercase, lowercase. So department as, and say department as D. So I give another name for department here, and then comma, and then the next one. Okay, as for example, as L. And so you can give any name to it, you know, doesn't matter, like you don't even have to use one character, you can use two. So for example, I put this DL, for example, that's fine too. But usually you give shorter name than the table itself. Otherwise, you're just using this, that's good enough, right? And so you can give another name to it. And once in the front part, you give a different name. You can use this name to specify attributes. You don't need to do department anymore. You still can. Okay, there's nothing wrong. You do department.d number. Instead, you can just say d.d number. So that's just easier, right? You have like only one character row, two character to type, compared to type the whole table name. Sometimes in order to give meaningful name, our table name can be quite long. And that's why people, you know, within the query define another name and to use it. So similar here, I can use DL to do that. Okay, so for the D name and delocation, there's no ambiguity. You don't need to do it. So as a habit, you see many SQL programmer, okay, some of them at least, when they use alias, they try to use it everywhere. So they will say D dot and with no space, right? So we'll do DL dot delocation, something like that. Again, this part, you don't need it, okay? This is optional, you put it or not. So at least one thing you can see, another approach is using alias. Instead of the whole table name, I can use alias in the query. And this is another way to solve ambiguity. Okay, so do we need things in here? Answer is no. Here, every single one, no ambiguity, right? But some people, when they get used to use it, use alias, sometimes you see programmers, no matter there's ambiguity or not, they always use alias, and that's fine, more like a programming habit. So people do SP, as D, as E, something like that, and they do P dot location, things like that. So they can do this even when it is not necessary. The good thing about using that is if you have things like a P dot P location, it show the readers, whoever read this, okay, they can easily say, oh, P is coming from here. So definitely this P location coming from here. So even without a schema, they can easily see where each attribute is coming from. So if you say P, and this will be D, right? Something like that. So they can easily see where this one coming from. And also relatively for programmers like us to like a kind of like a double check, did I do things right? It's coming from there or not? But again, this is optional. You use it or you don't use it. You don't lose any points in this question. And so if we go back to this one, right? So if you handle this, I show you two possible ways, and either way is fine, whichever you want to use, but you have to do something to handle the ambiguity. Okay. So now let's introduce this. And so for this one, if we have a query like this, I need employee's name and name of supervisor, right? So when we have a query like this, we basically utilize the employee table. And when we utilize the employee table, we actually utilize them using different role. So we can have two different roles for the employee table. One is the role for supervisee, one is the role of supervisor. So we do use the table twice, but each time we use different purpose. And so now we can answer the query like this. So we can say table name, and then we can put the area names here like E and S. So there are two different copies. In this case, two different copies. E is one copy, S is another copy. And when we do this, okay, we do not need to care about other attributes, but we do need to care about anything show up in the where and the select to make sure anything show up here has no ambiguity. So in this case, well, if we just simply say super SSN equal to SSN, this is wrong because we don't know the supervisor SSN is coming from where. It is in this copy, and this is also in this copy. Same thing. SSN is in this copy, SSN is also in that copy. So this is confusing what you try to do. So in this case, we have to restrict where this one coming from, and that is coming from here. So coming from the employee copy, right? So this copy, supervisee copy, equals to the copy of social security number in the supervisor one. So in the relation algebra, whenever we use the same table twice, we can do step by step. We can rename attributes to avoid ambiguity, right? We can always change it to a different name. Instead of SSN, we can change to some other names. And here, we simply just using alias to replace, to use alias to restrict what super SSN belongs to. So belong to the employee copy, for example. Okay, similarly in the select statement, we want to specify the first name is coming from employee. Then this first name coming from the supervisor. So think about query processor is a computer program, right? So when query processor reading this, they know, oh, this is the one coming from this copy. So I should grab values from here. Okay, so this part, this is the SQL standard. So in my slides, they are actually SQL standard, but this one doesn't work in MySQL. So for MySQL, you have to do this. So both this page and the previous page, they are acceptable in SQL standard, but this particular one is supported in MySQL. Okay, so let's see. We have employee as E and employee as S. So it's just like a slightly different syntax. So this, I think, is actually more clear because it shows, this is one copy coming from employee, and like similar to another table, I have another copy of employee, and then I use them in the select and where. Okay, hope this is clear. Okay. So let's see, another thing is unspecified where clause. When we do the delete, we actually cover something similar here. So the where clause actually is optional. And whenever we don't have, it's equal to where true, means we don't have filter. Everything's, pass, right? Okay, and so all type of the relation in the from are selected. So like in this case, you see select SSN from employee. It will give you all the social security numbers of all employee. No conditions, no filtering. Okay, so that's why this one answered this query for all of them. So where, nowhere is where true. Be careful if you have if you have more than one tables here. That means by default, that's the Cartesian product. So this means you're going to produce all the SSN combined with all the department number, right? Department name. So that's may be the one the query asked, maybe not. Another thing, common mistake is we do have where. Okay, so for example, where I say last name equal to Smith, things like that. Okay, all right. So we do have where, but when we say this is a still Cartesian product, just because you don't have any restrictions or conditions to make table join, right? Remember join, we need to have condition. So in this case, although we have where, but this is not the condition to join them. You don't restrict how they related. So in this case, it's still the Cartesian product of that. And if we say I want to have the employee whose last name is Smith, and I want to see their SSN and which department the employee works for, then this answer is wrong. The reason wrong, we're missing a condition here. Okay, so one more thing I want you to pay attention is you cannot use a comma in the where, because remember the whole thing is I sent 1,000 times. It's not memorization, about you understand the where part give you true or false eventually, right? So this one doesn't tell the query processor how this condition related. So you, for example, you put and, that will be good, right? So you don't use that. And here you don't put and, this is simply syntax, you use comma here. So in this query, okay, so when we see the query output, we basically want to see how many columns. So here, so this one has SSN and has D name, right, column. And it depends on we have a condition or not. Say, for example, we don't have this at all, right? So if we just do this, then what happened is this is going to have, so say I have 2 employee SSN, 1 and 2, right? And then this one will combine with all the department, like computer science, research, EE. So you have 1, 1, 1 like that. And second one will be the same case. You have CSE. So that's the Cartesian product, right? So that may not be the one you want to see. Yeah. So that's the output. Okay. So now we're ready to talk about how to convert. So now we're ready to talk about how to convert a bag into a set. Okay. Depends on the query. Sometimes we want to convert, sometimes we don't. So for example, this query, this one will say, I want to see all the salary of employee. So we say, if we do this, let me give this example first. So this one going to have a salary column and say, I have a salary 30K, 50K, 30K, 100K, 80K, and 30K again. So like this. Okay, so this is, I have how many? 6 employees, and that's the salary. Every single one salary is here. That's by default what this query can generate. And what happens if I want to see only distinct salary? So I don't want to see repeating salary. Say how many, what kind of salary I afford from my employee, distinct one. Then this one will do the work. So this distinct, you can simply think, whichever query you already produced, you put a distinct at the beginning before the attribute list, it will simply convert it back into a set. So without this, it is a bag or whatever structure of the output. Okay, it doesn't matter what the structure, 1 column, 2 column, 3 column, as long as a query, it has default as a bag. So the possibly no duplicates, depends on, maybe in that given company, everyone has different salary, then it's actually already distinct. But distinct here allow us to convert existing bag into a set. So in this case, when we do distinct, what happens is this is gone and this is gone. That's it, right? And you may ask which one is removed. It doesn't matter because they are exactly the same, right? So which one gets removed doesn't matter. So as a result, you're going to see something like this. Okay, also, we do not see the ordering of this. So the query result can be any ordering. It can be, this first can be, maybe 100K to the first one. So this is not decided when you run the query. However, we have control about the ordering. And I'm going to show you that very soon in a few slides. We're going to see we need another clause, order by order, to do that. Without that, it can be any order. Okay, so before I do the union operation, let's do an in-class exercise. So let's do this. Let me give you a relatively complicated one. So just utilize what we learned here. We haven't talked about nested query or any of those more complicated one, but just using the basic select from where we were to do a query like this. Let me see where probably here. Let's go to 01. So what I want to do is okay. So let me expand this a little bit. So I want to retrieve the employee last name. So what type of employee? This employee works on a project, right? So we have the works on table. We works on project, and this project is controlled by a department. And for this department, I know this department has a manager, and this manager's assistant is this one. Okay, I give you. Okay, I give you 4 minutes on this. All right, let's see how to do this. If we go back to this one, and we can see I need the employee's last name, right? So the employee table will do the work. Allow me to get the last name. Okay, that's good. And I need the employee works on a project. So you can see employee works on a project, right? So employee table works on table, project table. And this project is controlled by a department. So here, tell me controlled by this department. And this department, I know the manager assistant. So that's basically what I need. So how many tables? 1, 2, 3, 4. 4 tables. Solve the problem, right? Okay. Let's see how we answer that. Almost there. Yeah. Okay. So let's do a select. So let me just do from and where here. Okay, to save time, maybe using lowercase because I write lowercase much faster than uppercase. So let's see, I need the employee table, right? So because I need the last name, so employee table's there. And then I need works on table. Right, and so you can put all the table first, or after you put table, you can put a join condition, iterate to see which one you want to do. And then I have project table, right? And I have department table. Well, I try to save some space for the next exercise, but it looks weird when they, fill space. When you write a query, when you do the real query in any vendor's product, they are okay for space, so don't worry. Okay, so I have those tables here, and so let me specify the condition. So employee works on project, right? So this is the one condition I can do. That is SSN of employee equal to the ESSN. Employee works on project, right? And then for works on and project, I need to have P&O equal to the number here, right? Okay, so this employee works on project and the project's controlled by the department. So the other condition, how to say project controlled by the department, that's the DNUM equal to the number. Okay, so we figure out the harder one. And then the last one will be, so this one, manager assistant, right? So we know the manager assistant equal to this. And I'm okay here, right? No ambiguity, right? So any of them, they are coming from only one table. Any attribute show in the where, so I'm okay, writing this way right now. And then let me see the select statement. The only thing I need is the last name. And this is also only coming from employee, right? So no ambiguity. So the whole query, no ambiguity. We're just using 4 tables to join in order to answer the question. So let me double check. Did I miss anything? No. Okay, so that's for this query. And next class, we are going to modify this requirements, this query specification a little bit, and to utilize more things we learned. Okay, so that's all.